Welcome to the second day of our Digital Competence Days. Today we will talk about automated production. You will see our machines all fully automated. Let's just stop talking and watch the machines. Hi Torsten and Benny. Today everything is about automation, right? We're going to see a lot of machines which can work in full automatic mode, and you're going to show us how this is programmed, right?
Hi, Garrett. Yes, actually that's the case. We're going to show you a small demo how you easily can program our automation machines and how you can easily integrate them into your workflow.
Okay, let's go.
Yep.
Thank you.
Okay.
Hi, Benny. How do we
Torsten,
start?
how do we start? Okay, first of course, I will start here with our programming software, BySoft CAM. So here we have the software itself, and the cutting plan we are talking about here is this one here.
I think that's the status where we stopped yesterday with a manual production.
Exactly.
And now we have the cutting plan with the nesting done already, right?
Exactly. So as you can see, the entire nesting here is already finished. So the parts are programmed, the entire technology for cutting, bending, etc. is already set. Plus also here for the sorting itself, when I zoom in a little bit, you can see these grippers here, the magnetic grippers, they also have been set already.
Okay. What about maybe small parts, if I have small parts or micro joints on the parts?
Okay,
to
that's a
prevent
good
the
question.
tilting?
That's a good question. We already have solved the problem here with this small frame you can see over here. That's a so-called cluster frame. So the smaller parts which normally tilt, we have nested here within this small frame. We have put everything together with micro joints, and with this kind of cluster frame we can then easily lift off the entire frame as one single part, and then all parts get nested as well. It's no problem.
That's cool. So I can still integrate that into my automated sorting process.
Exactly, exactly.
And how do I configure now the sorting? I've seen that there are already the grippers positioned, but how do I tell the system where to put the sorted frames?
That's no problem. So here we have an integrated solution called Sort Editor, where we will get a simplified overview up here with the machine, with the cutting plan and so on. And here within the black box, this is the so-called stacking area, where we have the pallet configuration already set over here. And the easiest way to set the stacks for sorting is always to use the automatic solution from the software. And as you can see, the software puts all the parts on the relevant pallets, and that's it.
Okay, but can I adapt that? If I maybe have already other parts lying on pallets or whatever, just to adapt the configuration, is that possible?
Of course, no problem. So when you are not satisfied here with the sorting result, so with the position and stacks and so on, you can easily remove the stacks you're not satisfied with. So for example, remove them. And for the remaining parts here, just from the list, drag and drop the part to the location you like. You can also rotate the part if allowed, for example, and then put this part here on the center pallet. Same here for the next part, just drag and drop here again on the center pallet. And this part here, as you can see, it's a bigger one. So maybe here it's a good idea to place this part with one stack on the left pallet and with the other stack on the right pallet. This way we will have two stacks of two parts each. And the benefit, of course, here is that now the sorting system can always pick two parts at the same time and place them at the same time.
So you increase the sorting speed in the end?
A little bit, yes, a little bit.
Okay.
It's also calculated here, the sorting time. Now it's 2 minutes and 23 seconds, so I have spared a few seconds here with the sorting itself.
That's cool.
Yeah.
So now that sorting configuration, what do I need to do else?
Basically nothing. So as soon as the stacks are placed like that, if all the numbers are okay, the number of parts, then we can easily continue here with the export menu, and it's all just a matter now of exporting the program. Just checking, continue, continue, and in the end, we will get some sorting information here about the tool changes. So we have 2 cycles. Since we have 2 different magnet grippers, we can see that all 12 parts are sorted. And also here the sorting time, again displayed with 2 minutes and 23 seconds. And basically that's it. So simply continue from this point on. You can see the cutting plan now has been exported. So you will get one single file, and this one contains the cutting technology, plus also the sorting technology. And that's it.
That's very easy. Okay, and now when we have the sorted parts, how do we go on when we have bending parts as well?
Yep.
I think now we also should program then the robot to bend parts.
Yeah, of
How is
course.
that done?
So for the bend parts, it depends a little bit if you want to bend them manually, like for example the big blue part here. So this is a band part we will bend manually, but we also have some parts here which we want to bend on the mobile bending robot. So this small blue part here, this is the one we have decided to do on this one. So again, the entire technology for cutting, bending, and so on has been already set. The only thing missing here on this part is to adapt the robot technology. And this robot technology can be added here with this robot manager module over here.
So we start the tool just out of the same software, and it's seamlessly integrated.
Exactly. So here with the robot manager module, we have the possibility now to add this robot technology. So here we will select the part first. That's this one here. Open. Now it's loading the workpiece and the cell.
It needs to load a lot of data, right?
There is a lot of data in the background, yes. So we have the entire cell which needs to be loaded. We also have the gripper configuration which has to be loaded and so on. So this takes a few seconds, and after that we can see how the robot programming is done. And here we go. So as you can see, here the robot cell, full 3D preview with all the elements like this. So the bending machine, the cell, the conveyor belt, and so on. And I can simplify the view here a little bit to make my task a bit easier.
Okay, so you really have a 3D view of the robot and the bending machine to see all the relevant details.
Exactly.
Okay.
So the first task here for me is to check the robot movement. So now the software checks the entire robot program for any kind of collisions, problems, stuff like that.
So there already will be an automatically generated robot program.
Well,
also
in the end,
calculated.
what the software will do automatically are all these robot steps over here. So each and every step is created by the software full automatically.
Okay.
And my task as the operator basically is simply to check all these positions to see if they will work or not. So in this case, as you can see, everything seems to be great. So all the steps are green here.
Okay.
So if we start the simulation, here you can see now the robot, which runs in simulation speed. That's not real-time speed. And during the simulation, we will have a constant check for any kind of problems like collisions, or if the robot has an error with his axis movements and stuff like that. So this is simulated over here, as you can see. And also all the paths here on the right-hand side, you can see everything is checked already, so it's green and finished. It will work without any problems. But of course, in reality, sometimes you will encounter several smaller problems you need to fix. And in order to show this, I will provoke something like that.
What could such an error be, for example?
For example, here, these two paths I will delete on purpose to check what we have. And as you can see, we already have some red elements. So this is how it could be when you start from zero, creating such a robot program. You will encounter such problems. And to solve these things, it's always a good thing to use the simulation. So here, from the former robot step here, I will start simulating to see what kind of problems we have. And as you just saw here with the regrip station, we had a collision. So what is the solution in this case? Of course, you can always try to find a manual solution by moving the steps, creating new steps, or taking some other actions, but the software also offers here an automatic function. So with one single click here, the software will now try to calculate a full automatic solution by inserting additional robot steps in order to avoid the entire problem.
Okay. And so you get a solution proposed, and you can say, okay, that's fine, or can you also adapt that solution, or do you need to manually interact?
Of course, or you can also make the software calculate again, until you're satisfied with the solution the software found. So as you can see, a new path here was created, and if I simulate the entire thing again, then the robot will move without any collisions.
That's great. There's no collision now, and
Yep.
now he can bend the part easily, right?
Exactly. So the robot will bring the part over to the machine, then the machine will clamp the part. So this is basically a very classic way to bend the part. Then after the bending is done, the robot will reposition itself, as you can see, pick the part again, going to the next bending operation, and so on.
So this is also very easy to program that robot. Now, what about I have maybe several stacks where I take the material from, or several stacks I need to place the material? Is it also
Exactly.
possible to tell the robot to use these?
No problem. As you can see here on the pickup pallet, we already have 2 stacks set over here, but maybe you want to have additional stacks here, maybe on the second pickup pallet to put more parts on it. And this is no problem here in the area stack pattern. I now have the possibility to modify either the existing stacks or create brand new ones if I like. So in order to create additional stacks here, I can simply first copy the stack pattern from pallet 1 to pallet 2, like this. And if I just want to create one stack here, I can remove the one here on the back side, so by simply removing the stacks. Also the pins here required to align the parts, you can easily just click on them to remove. Oops, like this. And the stack itself here, I can also move the position. As you can see also here with collision check, if I collide with any kind of object, it's automatically displayed. So simply put the stack here to a position that will work, and that's it.
It's really like in virtual, you already can program and configure the complete robot itself.
But of course, since I have now created a new stack, we also created new robot positions, which we need to check if the robot is able to reach these positions. So
But I assume that's also possible automatically again, right?
Of course, so just check. So now the robot is simulating again the new positions, the new movement, and so on. And if there is any error, it will be reported by the software. So now the check is finished. But as we can see now here in the path, we have a red element. So here, we need to check that. And as you can see here on front, again, we have some red elements here. So again, like before, let us check what kind of problem we have here using the simulation.
And there are
As you
some
can
collisions,
see,
right?
you see the stack is very, very close to the other objects here, and the robot movement is very tight, so here we will have a collision again. Of course, I could use the automatic calculation again to fix the problem, but as an experienced user, you can also try to find a manual solution by modifying the robot steps directly. So this robot step here, as you can see, the position of the part in the robot, I can easily modify by just picking these colored arrows here and move the part and the robot to another position. So in this case, just take it upwards a little bit and away a little bit from the other objects, and probably that's already it. So check again, and as you can see, the problem is solved like this as well.
Very easy and
Very
convenient.
easy, very user-friendly, as you can see. And then everything is green again. Also, all paths are green from here on. So that's it. Robot program finished. Export to the machine, ready to go.
So just again, without any click, you just can run smoothly the automation function and integrate a robot programming.
Exactly.
Very easy. It hasn't taken 5 minutes for us to do so.
Yeah, to do so. Very, very easy, very user-friendly.
Okay, but when we now look to the overall workflow on the shop floor, we also maybe now need to integrate several machines, assign the jobs for the sorting, and assign the next job for the robot. How do we do that? Do we
That's
have
also
any tool for
possible.
that as well?
Yeah, we have a tool for that. So let me just close the robot manager for now. For the task you're asking for here, we have this plant manager module, which you can use for that. So run this plant manager. Now it's making a connections with the server in the background. Then just log in, like this. And here on the right-hand side, we now have different categories where I can check, for example, first the orders. So here within the orders, this is basically the place where the plant manager gathers all the production orders together. So these production orders either are created manually here in the plant manager, Or we also have the possibility to connect the plant manager with an ERP system. So then the ERP system is capable of generating these orders, and the plant manager will import this information automatically.
So you will directly have the same view as in the ERP system and see what orders are there and how to execute
More or
them.
less, exactly.
Perfect.
So here, for each and every order, as you can see, we have the number of parts inside with each order. We have the deadlines here. We have the processes. So this is just cutting for now. But here, for example, whoops, on this one, we also have parts with multiple operations, like cutting and bending in this case here. And you can also see the progress of each step all the time over here.
How would you go on with such an example if you want to produce this part now? What would be the next step now when we have the order?
Basically, the next step, that's a good question, is either wait until the plant manager does everything full automatically. So the plant manager has the possibility to automatically create the nestings, depending on the deadlines and so on. So this is just a matter of waiting. Or if I'm not willing to wait, I can also jump into action manually here within the jobs section, where I have the possibility then to prepare a job manually. So here, as you can see, we have already several nestings created for several machine types, as you can see.
Yes.
And all these nestings are done automatically by the plant manager. But if you want to jump in manually, simply use the job wizard and then select the part in question. At the moment, I do not have any parts remaining anymore for selection, since all parts have been nested already.
Okay.
But then simply select the parts you want to nest, then make the nesting manually, and that's it.
Okay. Maybe let's take the part we just recently looked at, the nesting we've configured for the sorting and the bending. Can we now assign that to a laser machine so that will be cutted and bended afterwards?
So let's just check one of these parts here within the nesting. So I have to check where the nestings are. So here, for this part, in this order, we have 4 different nestings, as you can see.
Okay.
And from here, I can simply jump over to the job. The software is highlighting here the nesting in question in the end. And from this point on, it's basically just a matter to then release this job, send it to the machine, wait for the feedback, and that's it. So in this case here, simply select the job in question, release the job. Then the job here is considered to be released, so ready to cut. And if I'm happy with that, send to the machine right away. And from this point on here now, the plant manager simply waits until the job is cut at the machine. And as soon as the job is finished at the machine will send the feedback. The plant manager knows, job is finished, parts are finished. The plant manager also will get the effective production times for each and every part in the entire job, plus also the used raw material, etc. And this entire information then will also be sent back to the ERP system, if you like. So then also the ERP system knows exactly which job is finished, to which order the part belong, and how many parts are finished, and so on. So you have a system which works full automatically throughout everything.
That sounds really perfect and smoothly integrated into the overall workflow.
Very easy to use, very good overview. You have all knowledge about which part is finished, how the process of each order is, and so on. Everything visible here in the Plant Manager.
Thank you very much, Benny. I think that's a good thing to see, that we have integrated all that software modules in one part and seamlessly integrated to integrate that into the automated factory.
Thank you, Benny. Thank you, Torsten. That all looks pretty easy to me. Let's go and see this on the machine now.
Thank you very much, Garrett.
Thank you.
Hello, Cosimo.
Ciao, Gerrit.
Hi, we're standing in front of a ByStar fiber,
Yep.
a BySort, a ByTrans modular,
Yes, correct.
and a double tower, right?
Yes, exactly.
Okay, can you give us all the details?
Of course. Today
you.
I will present you the Bystronic solution for the autonomous cutting cell, able to run the entire process from the loading to the unloading. This solution is automated, flexible, and customizable. Automated, as I told you, from the loading to unloading to enable efficient and continuous production with low manpower required. Flexible because we are able to manage different cutting plans with also sub-sheet format, like big part removal, residual sheet management, plastic sheet separator, and obviously the sorting process, as we'll see during our demo. Finally, customizable because we customize it to your needs to give you the best choice. But let's go more in detail about this system, composed of a ByStar fiber 12 kilowatt, a ByTrans modular 3 levels with BySort, and a double tower system. This is one of our standard configuration, but as I anticipated some seconds ago, we can customize it to meet all your requirements and all your needs. The goal of this system is to achieve an overall reliable and efficient automated process. That's why the ByStar fiber is equipped as a first step with the tilt prevention function that avoid any tilted parts during the cutting plan by rearranging the piercing position. Concerning the load and unload automation here, the ByTrans modular is a modular and efficient solution for material sheet handling, from the loading until the sorting or unloading with the fork system. The modularity of the system enables you to configure it as you prefer to satisfy all your needs of material flows, but also your shop floor layout restrictions. The system is generally combined with the 3015 and 4020 laser cutting machines, and in this particular case, it is equipped with the scratch-free forks to avoid any scratches on the final part while unloading the full cut sheet with the fork system. The modularity of the system enables you to have different material flows. For giving you an example, with a ByTrans modular 3 levels, BySort, and a tower system, we are able to sort our parts on pallets placed on the floor, like we'll see in a few seconds, but you are also able to sort your parts over the vacuum unit cassette to store back in the tower your sorted parts. But now let's move in front of the cutting cell for the sorting operations. Now we are going to exchange the tables with a new raw material sheet that is coming inside the laser, and the already cut sheets that are coming out. As you can see, the sorting will start automatically. And this BySort is a single bridge with two-head solution designed for the unloading of the final part in a total automatic and unmanned way. The grippers placed on each head of the BySort, as you have seen now, but also we'll see in a few seconds, can be automatically changed by the system in case of different parts to be picked. Now we're using two big magnetic grippers, but in a few seconds we are going to change it with a smaller one for sorting smaller parts as well. We offer a wide range of standard grippers, but if you have a particular needs for a particular parts to be sorted, we can easily customize the grippers with you to sort in the best way possible. As you can see now, the BySort is changing automatically the grippers because we are going to sort smaller parts. And we are able to manage the entire cutting cell from one software. So from BySoft CAM environment, you will be able to manage the cutting, the load and unload, and the sorting operation as well. Then, talking about the tower system that we have in the background while we are finishing the sorting, we have a double tower system with an I/O shuttle designed for loading new raw material inside the tower and for unloading the already sorted parts or the cut sheets unloaded with the fork system. We offer a wide range of tower layout and tower heights to satisfy all your needs of storing, but also your restriction in terms of height of the roof of the warehouse. As you can see now, the double fork system is coming over the laser shuttle table to unload the remaining skeleton over the L2 additional carriage. And at the same time, the vacuum unit will load new raw material from the tower cassette to enable faster cycle times and continuous production as well. So summarizing, we could say that this cutting cell is easy to manage thanks to the BySoft CAM software that enable you to manage the entire process from one environment. It is completely automated, as you are seeing, from the loading until the sorting and unloading of the skeleton. And finally, it is highly customizable to meet all your requirements and all your needs. And now the production can continue.
Wow, it looks like this machine can run 24/7, right?
Of course, it can.
Okay, let's go and see some bending automation. Right next door we have our Xpert 80 with a mobile bending robot. Let's go. Hi Sebastian,
Hi Garrett.
nice to see you again.
Me too.
This looks pretty compact. What is it?
This is our mobile bending robot connected with our Xpert 80 right now. So a complete mobile bending automation.
Why is it called mobile?
Because you can slide it easily away from the machine and you can bend manually and, of course, you see right now with the robot.
Okay, so if I do some manual production and I go home at night, I can push this in front of the machine and it will work during the night?
Yes.
Automatically?
So that's the cool thing. If you have normal smaller batches in your daily shift, then you can bend the parts manually with our Xpert 1480. And if you have repeating batches and a high amount of pieces and batches, then you can bend it automatically with our mobile bending cell, mobile bending robot.
Okay, so it fits on an Xpert 80 and an Xpert 40.
Yes, that's the cool thing, that you are really modular with this machine.
And if I already have an Xpert 80, can I then just buy the robot and put it in front?
Yes, because it's retrofit able.
Okay. How many parts can I put in this cell?
So you see right now here 3 stacks. With one stack you can stable up to 100 millimeter. For this part, this means we can stable 100 parts at one stack because we have the height of 100 millimeter per stack. And it is unlimited with the parts, because if you have smaller parts, you can put more parts at one pallet.
Okay, so right now I can do 300 parts.
Yes, right now you are able to bend 300 parts automatically, yes.
And somebody told me that the machine can do 200 to 300 bends per hour, is that right?
Yes.
Okay, so it can run 8 hours, no problem.
It can run more than 8 hours, this is no problem. So you have always to refill the parts, of course.
What else do I see here? I see the conveyor belt. I can see little stacks here. How high can the robot stack the parts so they can still fit out?
So you can stack up to 250 millimeters, so that's the height of the conveyor belt. So more or less, a little bit less than 250 millimeters.
So I could stack like 1,000 parts on this conveyor belt.
So now at the end you have to put the parts from the conveyor belt, but then you can stack again.
Okay. Is there another option, or do we only have the conveyor belt?
Yes, it's the option. So the conveyor belt is perfectly for parts. They have a really high quality surface.
Yeah.
And for normal parts, for example, of course, like this, you have a slide also at the side as an option.
Okay. And once it has finished one stack, do I need to do something, or does it automatically go to the next one?
No, it's automatically go to the next stack, so you can easily work with all 3 stacks.
Okay. Can you explain the cycle, what it does?
Yes, of course. So at first you saw it puts the part, grip the part, in this case with a magnetic gripper. Then we have our alignment station. With the alignment station we look that we grip the part in a perfect way. So, and then we start with bending. Right now we have 8 steps of bending, and we are also able to follow the part with our grippers and lift the part with our grippers. And if we have to change the parts, then we could also use our regrip station at the left upper side of the machine.
And how does the robot know that it touches the back gauge fingers?
Because the back gauge fingers have some clicks, and he has to push these clicks. Then he knows, okay, he has the connection with the back gauge fingers, and then we can bend.
All right. So if I have a very difficult part, I can send you a file, and then you will design the gripper for me?
This is also possible.
Yeah.
So that's one option. But you can also build your own grippers and bring it to the machine.
Okay,
So-
nice. And then I can just pull it off and bend manually.
Yes, in 50 minutes you have a manual bending machine and an automation transfer and an automation bending machine. So it's very flexible. It's the most flexible bending machine we have.
And I also heard that there is another kind of pellet, a bigger one.
Yes, so right now you see 2 pellets in front. So it's also an option and a feature that we have also, that we have 1 pellet, so you can handle bigger parts.
Okay, bigger parts than, like this one is like, looks like 300 times 400,
Yes,
300 times
yes.
600.
So the biggest part right now you can handle at this at 1 pellet is 600 by 300 millimeters, and with 1 plate, with 1 pellet, you can handle also bigger parts.
Okay. Wow, I think we know everything now. Shall we go and have a look at the bigger cell?
Yes, I hope
Okay,
so.
thank you. Let's
You're
go.
welcome.
Sebastian, hi.
Hi, Garrett.
We're in front of our big bending cell.
Yes,
This is an Xpert Pro.
100 tons.
Okay.
So, but also available up to 320 tons.
Okay, so this is a fully automatic bending cell, right?
Yes, completely without operator, perfectly for bigger parts and more exhausting parts for the operators.
Okay, so why doesn't it bend?
Because we have only to push 1 button and then we can start with the bending process.
Okay.
So at first with the tool changing process, of course. So you see right now, we are also able to automatically tool changing, so we can also handle big tools up to 550 millimeters and store in our tool shelves up to 37 meters of tools.
So if I look at it, it takes like 15 seconds to get 1 tool in?
Yes.
Okay,
So
that's
no
pretty
long
quick.
time, not long time. So very quick.
How
and
many
easy.
tools can I store?
37 meters. as I
37
mentioned.
meters, you
Yes.
said that already, right? Okay. So once it's put the tools in, what's this going to do next?
So the next step is that we need a gripper for the parts. So
Okay.
then we have in front 5 stations of gripping. So, and with them we can handle a lot of different amounts of tools and applications.
Okay, so I can have 5 different grippers.
Yes, in this case 5.
So that means that I can do 5 different parts.
Of course.
Okay.
So if you have a high range and high amount of different parts, you can store directly at the machine 5 grippers, and at the side of the machine we are also able to store more grippers, but this you have to manually put in the gripper stations.
Okay. So now it's going to change the gripper. It's putting the gripper changer, tool changing gripper away.
Yes,
It will get another one.
you see how it easy will go. Then it takes the gripper what we need for the part, and directly after that we start with our bending process. So
Okay.
So at first, of course, we have to put the parts, grip the parts. Then we have at the right side our alignment station that we put the part in a correct way, and then it will go easy and fast. We bend the parts.
Okay. I can see the stack here. It looks like I can put a really high stack of parts there.
Yes, the stack is 300 millimeter high, so you can put parts up to 300 millimeters to this stack, to
Okay.
one stack.
So these parts are 1.5 millimeter thick, so I can put 200 of these parts, one on top of the other?
400, I believe,
400, okay. On both pallets then?
on both pallets.
Yeah,
Yes.
yeah, okay.
So, and now you see how easy it is to bend parts, and if you have parts there where you need 2 or 3 operators to handle the parts, this work will do our tool changer, our bending cell completely automatically.
Okay.
So it's no exhausting work more for the operator.
What is the heaviest part I can bend in a cell like this?
So up to 165 kilograms we can handle with our bending cell.
So 165, you would already need a crane on a normal press brake?
Yes, normal
Okay.
and normal crane and bending aids, of course,
Yes.
and maybe 3 operators, 4
All right.
operators.
And this one does it all by itself?
Yes, so you need only one machine and one cell, and no 4 operators, so they can do other works.
Okay. So if I do a quick calculations, 400 parts, this part takes like 4 minutes, right?
Yeah.
So
completely.
that means that I can bend like almost 24 hours the same part
Yes,
with no operators.
with no operators, with no stops. So, and after the 24 hours, you can do another part, of course.
Okay. So how do I get the parts? How do I make these stacks? Is there a program to do this?
So we have to do this in our robot managing software.
Okay.
So we will also see the robot managing software, and then we can easily program the part for the robot, and of course the stacks where we have to put the ready bent parts on.
And if I make a stack of parts like this,
Yeah.
can I then just copy it to the next pallet, the next pallet, the next
Yes,
pallet?
of course.
So I only need to do it once?
Yes. So
Okay.
one work and has a lot of effort, not more effort to do it to the other pallets.
All right.
So, and you see in front, we have 1, 2, 3, 4, 5, 6 pallets. So it's easy to work with more parts at the pallets.
Okay.
So,
It looks like it's going pretty quickly, eh? I
Yeah.
cannot bend the part like this fast.
no. So, because above all, for bigger parts, you have to handle it a lot. So you have to change it, turn it around, and if you have big parts, you need more operators. And
Yes.
with more operators, you have more maybe causes of wrong parts and better quality.
Okay.
And if you bend this automatically, you have always high accuracy and high quality with all amount of parts we bend.
So we said before that the heaviest part is 165 kilos.
Yes.
What is the biggest part in
The biggest
dimension?
part, up to 3 meters by 1.5 meters.
Okay, that's huge.
Yes, really huge. So it's one complete part of sheet metal.
And the robot
Production.
can follow the parts up.
Yes, we have 2 more functions. So we can follow the part up so that we go with the part, and we have a lifting function. That means if the upper beam goes high, then we follow the upper beam with the part and can easily put it out of the robot.
Okay.
So
So
with the
another
robot.
question just came into my mind. If I have a bigger part, 1.5 meter,
Yeah.
how do I put the pellets? Where's the pellet?
So, of course, you have in this case 6 pellets, but it's also able to have bigger pellets at the complete length of the pellet stations.
Okay. And I put the parts in from that door over there, right?
Yes.
Now, is it possible that I put my flat parts here?
Yes, of course.
How do I do that? Do I need to make a new
So-
program?
No, you have not to do another program for this. You have only to change the positioning of the parts, and that's really easy. So, and also you have different kinds of layout what you could do with our bending cell, and then it fits perfectly into your production.
Okay.
So
I see some different layouts on the screen here. Can you explain them?
yes, of course. right now, as I mentioned before, we have different kinds of layouts. So the first one you see is similar to that. And here we have a smaller track. That means if we need a smaller bending cell, then we can also adapt this to the layout. And if you need the tool shelves at the right side, it's also no problem. So and you have then the alignment station in the back of the bending cell.
So this track is already longer, right?
Yes, this track is longer. In the first layout we have a smaller layer. We have a smaller track. So if you need a smaller bending cell, and the third one is with a really extended track, and there you see we have more and bigger pallets for bigger parts. So and then we have the tool shelves at the back of the bending cell.
And I also see I have a lot more gripper stations, right?
Yes, yes.
Okay.
So for high amount of different applications.
What's the longest track I can have?
The longest track, approximate 10, 12 meters.
Okay.
So that's really long, I believe.
All right. And if I go one step further, oh, here it is already. Now I can see that I can actually automatically input the parts, right?
Yes. So we have a storage, or you have the option to have a storage connection directly at the machine. That means your material goes directly into the machine, also automatically, and you have a completely flow of parts.
Okay. That looks very impressive. What if I want to do more automation? If I want to, can I get these parts out automatically also?
Yes, yes. With AGVs, this is possible.
Okay.
And I think we will also see it tomorrow with our smart factory solution, and that's a great opportunity and great possibility to integrate our bending cell in this.
Okay, so this is what we're going to see tomorrow, right? One last question.
Yes.
If I go home and the robot is... Hi Ramesh.
Hello, Garrett.
Bystronic service for a trustful long-term partnership. I've heard about this 360 thing. What is it exactly?
The 360 Customer Advisor is just another way that Bystronic looks to add value each and every time we get the opportunity to service our customers' machines.
Okay.
If you allow, I can tell you a bit more about this.
Yeah, let's have a look.
So I'm going to start with an example, a situation that we're all very familiar with. And this is when you bring your car into the mechanic. Imagine you bring your car in to fix a broken light bulb. And the mechanic does exactly what you asked, fixes that light bulb, and hands you back your keys. You're driving home, and all of a sudden, you need to pull over because your car is about to break down. You start to realize that the mechanic did nothing else but fix that light bulb. This, of course, leaves you in a situation where you can't use your car, and you're very frustrated.
Definitely.
Now, imagine a more proactive situation. And this is where you bring your car in for the exact same reason, but the key difference is that the mechanic takes a look everywhere else on your vehicle.
Okay.
At the end of the service, the mechanic advises you on any areas that can possibly cause harm to your car and leaves your car in a state to be able to be used at any time.
That would be ideal, right?
Absolutely. So Bystronic heavily realizes that the production of our customers' machines is one of the most important things to them. So because of that, the Bystronic Service Department has created the 360 Customer Advisor. The 360 takes a look at 4 areas on the machine, and that is the safety, the proficiency of the way the operators use the machine, the efficiency of the machine itself, and the quality of the parts being produced. We also take a look at different components, such as the cutting head, the bellows, and different motors as well.
Okay.
There's a list of other different components that we take a look at as well. Now, you must be wondering, well, how does this all work?
Yes, how does this all work?
Well, each and every time that Bystronic is able to do a maintenance on site at a customer or do a service repair, our technician will do this health check.
Okay, must be expensive, no?
Well, at the very end of our service, our technician will do a consultation with our customers, letting them know the strengths and the weaknesses of the machine. The best part is we offer this for free while we're on site. So what I urge you all to do is to definitely contact your local Bystronic. The 360 Customer Advisor is one of the most easiest ways to stay ahead of your production, to minimize the chance of downtime. When you speak with them, ask them, can I please have a 360? Can I get this arranged? And finally, let us, the true experts of these machines, help you and develop this long-term partnership. Thank you.
Sounds very good to me. Thank you, Ramesh.
Thank you, Garrett.
Hi, Jonas.
Hello, Gerrit.
Consumables and spare parts.
Yes, and how we create simplicity.
Can we talk about this?
Yeah, yes, please.
Okay.
Let's go it. Original Bystronic spare parts and consumables unleash the full potential of your laser cutting and bending system.
Okay.
For example, the nozzles shown here, developed and manufactured in Switzerland with outstanding quality, guarantees you a high, stable cutting process. A few benefits. You have less gas consumption. That means lower cost per cutting hour.
Yeah.
In addition, you have a really clean and nice cut on surfaces. And generally less post-processing. To summarize, with original parts, we guarantee you a very stable cutting process.
Sounds good to me.
Thanks, yes. Let's have a look at our campaign program. We have each month we have a promotion. For example, the promotion for about nozzles, or this month's promotion tooling.
Okay.
Yeah, please join our community to benefit from our promotions.
I definitely will.
Yeah,
Yeah.
profit.
ByCare, I've heard this is a new service from Bystronic. Can you explain something about it?
Yeah, let's talk about.
Okay, yeah.
Service has been around with Bystronic for more than 30 years. I would like to show you a few main benefits. Bystronic Care is a modular thing, similar to a mobile phone abo. It's not just an individual package, it's also peace of mind. By working closely together, we enable you to focus on your main tasks. Your daily challenges, such as planning the orders, producing with the right quality on time. In addition, you have to take care about your employees. Moreover, it's all about your machine availability, and this is exactly where we would like to support you.
Okay.
What does that mean? Experts and maintenance from Bystronic, with the goal to reduce downtime and, of course, to keep the value high of your machine. Same with your car. If you have a well-serviced car, it's worth more and it's much easier to sell. That's all about Bystronic Care.
And this will give me peace of mind, right?
Yes, of
Okay.
course.
Thank you, all clear.
Thank you, Gary.
Thank you for joining us on our second day of the Digital Competence Days. Today was all about automated production. You have seen our machines in the most efficient way. Tomorrow, we will show you a little bit of our smart factory. I hope you can join us again tomorrow.